Hello friends, welcome back to CS Classroom. In the previous video, we learned how to insert a new element into an array. We saw that inserting an element in the middle requires shifting elements towards the right. Now let's learn the opposite operation. Suppose one student leaves the class, or one product is removed from an online shopping list, or one song is deleted from your playlist. How do we remove that data from an array? This operation is called deletion. In today's video, we will learn deletion in arrays using simple examples, diagrams, algorithms and C program. So let's get started. So deletion means removing an existing element from the array. Example, I have an array with the elements 10, 20, 30, 40, 50. Delete 30. Okay. Result 10, 20, 40, 50. It seems simple, right? But there is one important issue. After removing an element, an empty space is created. Arrays cannot have gaps between elements. As per the definition of an array elements are contiguous elements. Array elements occupies consecutive memory locations. There would be no gaps between them. So that empty location must be filled. How? By shifting the remaining elements. So this is the key concept in array deletion. Deletion can happen in three situations: deleting the last element, deleting an element from the middle, deleting an element from a sorted array. Let's understand each one. So deletion from end, deleting the last element is the easiest operation. Nothing needs to be shifted. So we simply reduce the number of valid elements by 1. That's all. So let us look at this example. So I have an array 10, 20, 30, 40, 50. Okay. So this is our array 10, 20, 30, 40, 50. Now delete 50. Delete 50. That means, so previously I had index value 0, 1, 2, 3, 4. My upper bound was 4. Now I'll simply decrease my upper bound from 4 to 3. That means only this much I'll consider as my valid elements. I'll not consider the last element as my troop. The last element is not my team. Okay, that's simple. We simply reduce the number of valid elements by 1. That's all. So notice that we are not physically erasing 50 from the memory. We are simply reducing the upper bound. So the program now considers only the first 4 elements are the valid elements, and the last element is not from our team, and the last element does not belong to our array. Algorithm is very simple. Decrease the upper bound. Upper bound previously we had 4 and we need to decrement it with 1. So 4 will become 3. Upper bound is equal to upper bound minus 1. No shifting. So what is the time complexity? Time complexity is order of 1. We are not shifting any elements and we are not traversing through any loop or anything. So very efficient. Now comes the next case, deletion from middle. Interesting case. Suppose we delete 30. So I have an array 10, 20, 30, 40, 50. I just delete 30. Okay, immediately one empty location appears. Can we leave it empty? Absolutely not. Array elements must always remain continuous. Therefore, all remaining elements move one position towards the left. Observe carefully. Insertion required shifting to right. Okay. Deletion requires shifting to left. Remember the difference. Many students confuse these two operations. See the algorithm. This algorithm performs deletion. Start from the deleted position and copy every next element into the current location. That means you are doing shifting to left side. So you are taking I plus 1 and shifting it to I. So copy every next element to current location. Finally, decrease the size of the array because from your troop, from your team, one member is deleted, right? Previously, you had n members in your team. Now, one member is deleted, is removed from your team. So, your team size has become n minus 1. So, let us look at the C program. For, definitely we must use for. We start from the current position from where you deleted the element and remaining all elements I less than n minus 1, I plus plus. In insert operation, you started from last element and you traversed in the left direction. Okay. Now in deletion operation, you start from the position and go to the last element in right direction. So there we used I minus minus. Here we must use I plus plus. When you go in a forward direction, you always use I plus plus. And every time you take the next element and put in the current location. You take I plus one element and put in the ith location. And finally, after exiting from the loop, you successfully removed one element from your team, one element from the array. So array size is to be decreased from n to n minus 1. So simply write n minus minus. Okay. So this C program directly follows the deletion algorithm. Shift every element towards the left. Reduce the size. Done. Okay. So in a sorted array, how do you delete elements? Suppose our array has elements 1, 2, 3, 4, 5. Now delete 3. Okay. How do you find 3? How do you find 3? So I think you might know linear search. You compare starting from the first element. Is it equal to 3? Is the first element equal to 3? No. Then go to next element. Check the next element. Compare the next element. Is it equal to 3? No. Then check the next element. Is it equal to 3? Yes. So this is what the element that you wanted to delete. So this is what the position that you wanted to vacate and shift all the next elements, remaining elements to one position left. Okay. So first find the required value where your value is located exactly and delete it. Shift all the remaining elements to left side. Okay. So I plus 1 comes to I position. I plus 1 comes to I position. I plus 1 comes to I position. So the sorted order is still maintained. Exactly the same idea. So deleting the last element is very fast, which takes only order of 1 because it has no for loops, it has no shiftings. Deleting from the middle and deleting from a sorted array, they require shifting many elements. Okay. So as we always consider the in the worst case, every remaining element may need to move. So all the elements may need to move. Hence the time complexity for these two cases is order of n. Here is a simple trick to remember. Insertion creates space. So elements move towards the right. We need to create a new space for the new element to accommodate the new element. So elements move towards the right. Deletion removes the space. So elements move towards the left. Remember this forever. It will help you in interviews and exams. So here we shall look at a program. A program to delete a number from a given location in an array. So as usual, we have declared all the elements that we require along with position from where we want to delete the element and array. So first we are reading elements into array. Before reading elements of array, we are asking how many elements are there in the array and we are reading the size of the array as n. And then we are reading what are those n elements using scanf inside a for for I is equal to 0, I less than n, I plus plus. We are asking what is array of 0, what is array of 1, what is array of 2, like that. Every time we are reading the elements using ampersand symbol. And then we are asking from which position you want to delete. Okay. So position we are reading, and as I told you, starting from the position till the last element, all the remaining elements, you need to shift to left. So I is equal to position, I less than n minus 1, which is the last element, I plus plus. As you are going in the forward direction, you always increment the loop variable I plus plus. You take the next element and put in the current location. That means you take I plus 1 and put in the I. After removing one location successfully, your team size will be reduced by 1. So you need to decrement n. After deletion, what is the final array you are displaying again using a for? For I is equal to 0, I less than n, I plus plus. You are displaying all the elements. So this is what the C program. Let's summarize today's video. We learned deletion from end, deletion from middle, deletion from sorted array, algorithms, C program, and time complexity. Okay, now you can clearly differentiate insertion and deletion operations. So friends, today we have completed array deletion operations. You should now be able to understand how deletion works internally and why shifting is required. In our next video, we will learn another important operation on arrays, array merging, where we will combine two arrays into a single array and also see how to merge sorted arrays efficiently. If you found this video helpful, please like, share and subscribe to Mana CS Classroom. Thank you for watching. See you in the next video. Happy learning.